Alright, so this time we're doing Unit 3, which is Lines and Symbols. Introduction: various lines of drawings have different meanings. They may appear solid, broken, thick, or thin. Each is designed to help the blueprint reader make an interpretation. The standards for these lines were developed by the American National Standards Institute and American Society of Mechanical Engineers. These lines are commonly known as alphabet of lines. Figure 3.1, knowledge of these lines helps one visualize the part. Some lines show shape, size, center of holes, and inside of part. Others show dimensions, positions of parts, and simply aid the drafter in placing various views of drawing. So, showing here, the visible line is a thick line, usually 0.6 millimeters or 24 thou. A hidden line is thin, and it's usually 0.3 or 12 thou. Center line is thin, and it has a long and thin, or long, short, etc. It shows the center of whatever you're doing. A symmetry line is the same thing, except it has two thick lines on each side of the part, or line, to show that it has symmetry. A freehand break line is just a thick wavy line. A long break line is kind of like a heartbeat monitor. Long, then it's got some angles, then long angles, long. A dimension line, extension line, and leader line. So first is your dimension line. It actually shows you right here. It's going to be what actually shows you the dimension of the part. So this one being 4 inches. The leader line is the little arrow pointing to the dimension line. In this case, and then your extension line, it actually extends from the feature that you're measuring to show so that the dimension line can be on it. So all three of them are very different, but they are used similarly. Then you got your section line, just kind of little thin angled piece here. You got your cutting plane line, which is thick, and it's got the direction of your cut. Or the viewing line, same thing. So then you got phantom line or reference line. Long, short, long, short. And then you got your stitch line, which is, again, going to be thin, but it's going to be kind of line, short line all the way across. Or your stitch line can also be just dots. And then you got your chain line. So, thick, long, short. So visible lines, also called the visible edge or object lines, are heavy, solid lines. Figure 3.2, they generally show the outline of a visible edge of the part. So all of these here are object lines. They just typically show the outside of the part. Hidden lines, some objects have one or more hidden surfaces and cannot be seen in the given way. The hidden surfaces or invisible edges are represented on the drawing by a series of short dashes called hidden lines. So you can see in these three, you can actually see the bottom of this channel here. Well, on the side view, you couldn't actually see that, so that's why it's got a hidden line there. Extension lines are thin, solid lines that extend surfaces. Extension lines extend away from the surface without touching the object. Dimensions are usually placed between those extension lines. So your extension lines are actually the ones going straight up and down, or left and right, whichever way it may be. But your dimension line is actually the one that has the dimensions, so don't get those confused. Dimension lines are thin, solid lines that allow the distance being measured. Figure 3.4, at the end of each dimension line is an arrowhead. These points of the arrows touch the extension line. The space being dimension extends the tip on each arrow. Arrowheads may be open or solid and can vary in size. The size depends mostly in the dimension line, weight, and blueprint size. So like I said on this one, you can be in between for the 1.25, or you can be on the outside and be 0.25. Pretty much if you don't got enough room, then they'll put it on the outside. Center lines. Center lines are thin lines with alternate long and short dashes. They do not form part of an object, but they are used to show the location. As the name implies, center lines indicate centers. They are used to show centers of circles, arcs, or symmetrical points. So, center of the whole, and then center of the part, etc. Leader lines are similar in appearance to dimension lines. They consist of an inclined line with an arrow at the end of the dimension or surface being called out. The inclined line is attached to the horizontal leg at the end of which the dimension note is provided. So this is actually a leader line right here. Symmetry lines are used to show an object or a particular feature of an object is symmetrical. A symmetry line consists of center line having two dark parallel lines drawn at right angles to each end. The line indicates a plane which of the part which side of a feature is symmetrical. So this is symmetrical if you cut it this way, and this is symmetrical if you cut it this way. Break lines are often used to show the view of a part has been shortened or a portion of the part has been removed because the complete view is not required. Break lines may be dark, wavy, freehand lines to show the short breaks or thin line with zigzags to show long breaks. So, short break and long break. Oh well, long break, there it is. Phantom lines are long dashed lines used to indicate a position or absent part in relation to the view that is shown. Phantom lines are similar to cut and plane lines but are much lighter. With line breaks that are closer together, phantom lines views drawn in phantom clarity or clarify the drawing without the need of additional views. Phantom lines are also used to show mechanisms in alternate positions or how they connect the adjacent parts. Figure 3.9 phantom lines clearly or clarify the operation of the mechanism even though the view drawn in the phantom line may not be an actual part of drawing assembly. So pretty much it's showing that it's rotating around this axis. There's part and there's phantom line. Additional use for phantom lining includes applications of repetitive detail is required for drawing. Rather than to spend time drawing identical features, the drafter may use phantom lines to show the continuation of the feature. The method often applies to the long threaded shafts, springs, or gears. Application of symbols. Revised drawing standards developed by the American National Standard Institute and the American Society of Mechanical Engineers are being applied to most modern drawings. These standards encourage the use of symbols to replace words and notes of drawings. The practice reduces draft time, reducing the amount of written information of the drawing, and helps overcome the language barriers. Figure 311 shows some common symbols applied to prints. The application of most of these symbols is explained in the appropriate units that follow. So diameter, repetitive feature, radius, depth, countersink or counterbore, reference dimension, dimensions not to scale, basic dimension, square, and machining symbol. The former practice was to specify holes or diameters by calling out hole size using an abbreviation of the letter or the diameter DIA or D, and note that the process. Old method is going to be this one, so it's feature size and machining process. The new method is just going to be your diameter symbol and 0.5 or whatever. Square symbol right here is often used to show the single dimension applies a square shape. The use of square symbol preceding the dimension indicates that a feature called a figure out is a square. Specifying relative features or repetitive features is pretty much, so this symbol here is going to be 2 times, so you're going to replace it, or you're going to have this hole twice. So if it was 5 times, you'd have it 5 times. Alright, so showing the assignment you are going to have right here. Thank you.